Hello students, once again I welcome you all. I hope you all are understanding as well as enjoying this topic. This is the third video of this topic. Today, let me start with some of the examples from the exercise 3.1 which are expected for 1 mark question in the examination. The first example, construct a 2 cross 2 matrix. Capital A is equals to Aij, whose elements are given as, first example, Aij is equals to 2i minus j. Since the matrix is of order 2 cross 2, therefore there are 2 rows 1 and 2 and 2 columns. I stands for the number of rows and J stands for the number of columns. Therefore, this matrix containing 4 elements. If I is 1 and J is 1, we'll get an element A11. If I is 1 and J is 2, we'll get an element A22. Let me start finding A11 and A12 respectively. If I is 1, J is 1, we'll get A11. Therefore, 2 into 1 minus 1, that gives 2 minus 1 is equals to 1. I is 1, J is 2, we'll get 2 minus 2. Therefore, A12 is equals to 0. That comes in the first row of a required matrix. Similarly, if I is 2, J is 1, we'll get an element A21. Therefore, A21 is equals to I is 2, J is 1, we'll get 4 minus 1 is equals to 3. Likewise, if I is 2, J is 2, we'll get an element A22. Therefore, 4 minus 2 will get 2. Therefore, a matrix A is equals to, having the 4 elements in the first row 1 0 and second row 3 2. Students, this is the question for 1 marks. Therefore, by oral calculation we can find only the matrix A. We can represent directly A is equals to 1 0 3 2. Likewise, let me start with another example. Second example, Aij is equals to I divided by J. Let me start with Aij is equals to I divided by J. Since once again this matrix is of second order, therefore there are the 2 rows and 2 columns. Therefore the values of I are is equals to 1 comma 2 and J is equal to again 1 comma 2. If I is 1, J is 1, we'll get an element A11. Therefore 1 divided by 1 will get an element 1. Likewise, if I is 1, J is 2, we'll get an element is equals to I is 1, J is 2, we'll get 1 by 2. Similarly, if I is 2, J is 1, we'll get the second row first element, that is 2 divided by 1 is equals to 2. And if I is 2, J is 2, we'll get an element A22. 2 divided by 2, that gives an element 1. Therefore, the matrix capital A is equals to containing the elements 1, 1 by 2, 2 and 1. Similarly, we have the one more example of third order. Construct a matrix of order 3 cross 3 whose elements are A is equals to Aij. Let me begin with the first example. Aij is equals to 2i minus j. Since this matrix is of order 3, therefore I values are ranging from 1 to 3. J is also from 1 to 3. Therefore, in this case, we have the total 9 elements. Let me find the first element of this matrix A. I is 1, J is 1. We'll get an element A11. 2 ones are 2 minus 1 is equals to 2 minus 1 is 1. If I is 1, j is 2. I is 1, j is 2. We'll get an element A12. Therefore 2 ones are 2 minus 1, we'll get an element 0. If I is 1, j is 3. I is 1, j is 3. We'll get an element A13. So 2 ones are 2 minus 3. 2 minus 3 is equals to minus 1. Similarly, we'll go for the second row. I is 2, j is 1. We'll get an element A21. Therefore, it is 2 2s are 4 minus 1 is equals to 3. I is 2, j is 2. We'll get 2 2s are 4 minus 2 which is equals to 2. And second row, third element, I is 2, j is 3. We'll get an element 4 minus 3 which is equals to 1. Therefore, the second row elements in this matrix are 3, 2, 1. Finally, let me take the third row, first column, third row, second column. That is I is 3, j is 1, j is 2 and j is 3. We'll get an element A31. Replace I by 3 and j by 1. We'll get an element 6 minus 1 is equals to 5. I is 2, j is 2. We'll get an element 4. Finally, I is 3, j is 3. We'll get an element 6 minus 3 is equals to 3. Therefore, the matrix containing the last two elements 5, 4, 3. So this is a matrix of order containing 3 cross 3 elements. The remaining two example, students, you can take as an assignment for homework. Moving to the next example, construct a matrix of order 3 cross 4, 3 rows and 4 columns, where Aij is equals to, once again we have the element 2i minus j. Since this matrix is containing 3 rows and 4 columns, therefore the values of I are, it is 1, 2, 3, and the values of j are 1, 2, 3, 4. Let me find the first element of the matrix A. I is 1, j is 1. By replacing I and j value, we'll get an element 1. I is 1, j is 2. We'll get an element 2 minus 2, 0. I is 1, j is 3. We'll get an element 2 minus 3 is equals to minus 1. And in the first row, last element, I is 1, j is 4. It gives 2 minus 4 is equals to minus 2. Similarly, we can go for second row, first column, second column, third column and fourth column. That is I is 2, j is 1. I is 2, j is 2. Likewise, I is 2, j is 3 and I is 2, j is 4. Therefore, we will get an element A21. It is 2 2s are 4 minus 1 is equals to 3. I is 2, j is 2. We will get an element 2. I is 2, j is 3. We will get an element 4 minus 3 is equals to 1. And I is 2, j is 4. That gives 4 minus 4 is equals to 0. The final row of the same matrix, capital A is equals to I is 3, j is 4, j is 1. We'll get an element A31. We'll get 5. I is 3, j is 2. We'll get an element 4. I is 2, j is 3. We'll get an element 3. And finally, I is 3, j is 4. We'll get an element 6 minus 4 is equals to 2. Therefore, A is having the elements in the first row 1, 0, minus 1, minus 2. Second row elements are 3, 2, 1, 0. The last row elements are 5, 4, 3, 2. Therefore, this is a matrix of order 3 cross 4. Now, so far we have seen the elementary parts of or aspects of matrices. Now, hereafter we are going to study some algebraic operations on matrices. Students, we know there are basically 4 algebraic operations like addition, subtraction, multiplication and division. In this topic, we are going to study some algebraic operations on matrices like addition of 2 matrices, negative of a matrix, subtraction of 2 matrices, multiplication of matrix or multiplication of two matrices. Dear students, remember one note: the division of two matrices does not exist, or division of a matrix is not defined. Therefore, we are going to study only addition, subtraction, multiplication and negative of a matrix. Let me start with two matrices. To add the two matrices, we matrices of the same order. Look at this. Let A and B of two matrices of same order M cross N. Then the sum of the matrices is written as A plus B and is defined only if matrix A and B are of the same order. Therefore, here is one general example. If A is a matrix having the elements A11, A12 and second row elements are A21, A22. B is another matrix having the elements B11, B12 and B21, B22. Since the both matrices of the same order 2 cross 2, therefore the corresponding elements of the matrix will be added. Then A plus B is equals to the first element of the first matrix is added with the first element of the second matrix, that is corresponding elements of the second matrix. We will get an element A11 plus B11. Second element of the first matrix is added with corresponding element of the second matrix. We will get an element A12 plus B12. Similarly, we can add the second row elements. We will get A21 plus B21. We will get an element A21 plus B21. Finally, A22 plus B22 will get an element A22 plus B22. Therefore, the existing matrix is also of order 2 cross 2. We have an example here over. Let me start with the first example. Let capital A is equals to the matrix. First row elements are 5 minus 4, 9. Second row is 7 minus 3, 0. This is a matrix of order 2 cross 3. And B is another matrix. First row elements are 2, 6, 7 and second row elements are 3, 2, 12. This is a matrix of order again 2 cross 3. Since the matrix A and B are of the same order, then we find A plus B. And also we can find B plus A. Addition exists because of the same order. Let me start with addition. Consider A plus B. Matrix A plus matrix B. As we know by the definition of a matrix, we can add the corresponding elements of both the matrices. 5 plus 8, that gives 13. 13 is the first element of a matrix. Then corresponding elements of the both matrices, minus 4 plus 6, that gives plus 2. Then we have the element 9 plus 7, that gives 16. Similarly, we can add the corresponding elements of the second row of a both matrix. 7 plus 3, that gives 10, comma, minus 3 plus 2, it gives minus 1. And finally, 0 is added with the corresponding elements of the next matrix, that is 12. 0 plus 12 is equals to 12. Therefore, in this case, we have the matrix A plus B as 13, 2, 16, 10, minus 1, 12. Moving to the next type, that is next operation called negative of a matrix. The negative of a matrix is denoted by minus A, and we define it as minus A is equal to minus 1 into A. Is also a matrix of the same order. For example, if matrix A is equals to, it is of second order 2 cross 2. The elements of this matrix are 4. The order is 2 rows and 2 columns, therefore this is of second order. If A is equals to 7, 9, 5 minus 2, then find minus A. The solution goes like this. Minus A is equals to, let me write minus A as minus of 1 into matrix A it is. This is our matrix A, having the elements 7, 9 in the first row, 5 minus 2 in the second row. Multiplying by minus a to the every element of a given matrix. Therefore, minus 1 into 7, it becomes minus 7. Minus 1 into 9, that becomes minus 9. Minus 1 into 5, it becomes minus 5. And minus 1 into minus 2, it becomes plus 2. Therefore, the matrix minus a is having the elements minus 7, minus 9, minus 5 and 2. Therefore, this is called negative of a matrix A. Here order of A is 2 cross 2 and order of minus A is also 2 cross 2. Therefore, minus A is called the additive inverse of A. Moving to the next operation called subtraction. Let capital A and B be two matrices of the same order. In case of addition and subtraction, the matrices must have the same order. Then subtraction of A minus B is written as A minus B and is defined as A minus B is equals to, by subtracting the corresponding elements of both the matrices, we'll get a new element Aij minus Bij. For example, capital A is equals to a matrix of second order, 7, 9 in the first row, 5, minus 2 in the next row. Another matrix B is equals to, this is also of the same order. First row elements are 6 minus 7, second row elements are 11, 2. Therefore, find A minus B. You can take or you can try B minus A at home. Now, by solving these two matrices, A minus B can be written as 7 minus the corresponding element of the next matrix, 7 minus 6, that gives plus 1. 9 minus of minus 7, it gives 9 minus of minus 1 plus 7, it gives 16. Second, the corresponding element of the next matrix is 11. 5 minus 11, that gives minus 6. And the last element of the second row, that is minus 2, corresponding elements will be subtracted. Minus 2 minus 2, that gives minus 4. Therefore, the matrix A minus B is equals to 1, 16, minus 6, minus 4. Dear students, you can try B minus A at home. Therefore, if both the matrices A and B are same order, then addition and subtraction is possible. If the orders of A and B are different, the addition and subtraction does not exist. The one more operation which is important for the exam point of view. Students, let me start with multiplication of a matrix or multiplication of two matrices. Multiplication of a matrix by scalar is different and multiplication of a two matrices are different. To multiply the two matrix, we should have, or one should have, matrix A and B. The product of two matrices A and B is defined only if columns of A is equal to the number of rows of another matrix B. Students, look at here. If the order of matrix A, O stands for order of a matrix A, is equals to M cross N, and the order of the matrix B is equals to N cross P. As per the definition, M number of rows and N columns in a matrix A. N rows in a matrix B, P columns in a matrix B. If number of columns in a matrix A are equal to the number of rows in a matrix B, then AB exists. Then AB exists and we can find the matrix AB. Let me start solving one example so that it will be easy to understand. The existing matrix AB will be of order M cross P. The new matrix AB will be of order M cross P, where M stands for the number of rows in a matrix A and P stands for the number of columns in a matrix B. Therefore, the AB exists only if number of columns in a matrix A are equal to the number of rows in a matrix B. Let me start with one example. Consider a matrix A is equals to having the elements in the first row 1 minus 2, second row 2 3, and B is equals to the elements in the first row are 1 2 3, the elements in the next row are 2 3 1. Find AB if it exists and find BA if it exists. Students, let me start with the first one. Since in this case the order of A is equals to 2 cross 2 and order of B is equal to 2 cross 3. As per the product of two matrices, the number of columns in matrix A are equals to the number of rows in the matrix B. Therefore AB exists. And AB is of order 2 rows and 2 columns. Now let me start finding the product AB. Let AB is equals to, we will multiply as we have seen the product of the both matrices exist. The multiplication will goes by row and column wise. First row, first column. 1 into 1 plus, we can write the element, plus minus 2 into 2, that gives minus 2 into 2. This is the first element of a matrix AB. Similarly, the same row with second column. 1 into 2 plus minus 2 into 3. It gives minus 2 into 3. Likewise, the same row we can multiply with first row, third column. Therefore, 1 into 3, that gives 1 into 3 plus minus 2 into 1. It gives minus 2 into 1. Therefore, the first row, first column, first row, second column element, and first row, third column element. Similarly, we can multiply the second row, third column, and so on. Second row, first column. Corresponding elements of both rows and column will be multiplied and added. 2 into 1 will get 2 ones are 2, plus 3 into 2 will get an 3 cross 2. Same row with the next column. 2 into 2 will get an element 2 cross 2, plus 3 into 3 will get 3 3s are 9. Likewise, the same row with last column. 2 into 3 plus 3 into 1. Therefore, total we have 6 elements in a matrix. Therefore, after simplification, 1 ones are 1 plus minus 4, 1 minus 4, 1 twos are 2 plus of minus 6 will get 2 minus 6, 1 threes are 3 minus 2 will get 3 minus 2. And here in the second row, 2 ones are 2 plus 6 will get 2 plus 6, 2 twos are 4 plus 9 will get another element 4 plus 9. And the last element of the same matrix is 2 threes are 6 into 3, 3 ones are 3. Therefore, in the first row we have the elements like minus 3, minus 4, this is, dear student, plus 1 it is. This is plus 1. By mistake it is minus 1 written. The value of this element is plus 1. And second row elements are 8, 13, 9. Hence the solution of this matrix is AB is equals to minus 3, minus 4, minus 1, 8, 13, 9. Now we will moving to the next example in the same problem. B, we have to try for B. Now let me check whether the BA exists or not. Since the first matrix is our B, I will write the order of matrix B is equal to, it is 2 cross 3. You have to check whether the first BA exists or not. Now order of A is equals to 2 cross 2. Dear students, you can find out here the number of columns in the first matrix is not equal to the number of rows in the second matrix. These two are not same. Therefore, BA does not exist. Does not exist. If this condition is satisfied, then only we can say that BA exists. Otherwise, BA does not exist. Once again, the reason is the number of columns in B are not equal to the number of rows in A. Therefore, BA does not exist. The multiplication BA does not exist. Let me take one more example. Matrix A is equal to, first row elements are 3, minus 1, 3. Second row elements are minus 1, 0, 2. And matrix B is equals to 2, minus 3. Second row elements are 1, 0. Third row elements are 3, 1. Find AB and BA if it exists. Let me check first AB exists or not. We know that the order of a matrix A given here is, it is 2 cross 3. And order of the matrix B is equal to, it is 3 cross 2. Since the columns in A are equal to rows in B, therefore AB exists. Now students, let me find out AB matrix, because AB exists and AB is a matrix of order 2 cross 2. This we are left with 2 rows and 2 columns. Therefore, the multiplication is always row by column wise. In case of matrix multiplication, we are left with rows and columns. Therefore, our multiplication always goes by row and column. Let me begin with the first matrix, product of AB. AB is equals to matrix A elements in the first matrix 3, minus 1, 3, minus 1, 0, 2. Matrix B is equals to 2, 1, 2 and minus 3, 0, 1. Since AB exists, we multiply the elements row by column wise. First row with the first column. Therefore 3 into 2 plus minus 1 into 1 and 3 into 3, that gives 3, 1. This is the first element of AB. Likewise, we multiply the same row with second column. Same row with the second column. First row with the second column. Therefore 3 into minus 3 plus minus 1 into 0 and 3 into 1. That is the last element of the first matrix. After simplification, we will get 6 minus 1 plus 9 and minus 9, 0, 3. We will get an element 14 and minus 6 after simplification. Similarly, we multiply the second row with first column, second column and third column respectively. Therefore, here for second row will get multiplied to the first column. Here we have the element minus 1 into 2 plus 0 into 1 plus 2 into 3. We get this element of AB. Likewise, the same row we can multiply to the last column. Therefore, here the second row with the second column, minus 1 into minus 3 will get plus 3. 0 into 0 will get 0, and last element of the first matrix multiplied with last element of the second matrix. Therefore, 2 into 1. Therefore, after simplification in the second row, we have the elements like minus 2, 0, 6. And the last two elements are minus 1 into minus 1 is plus 3. 0 into 0 is 0. And 2 into 1 is 2. Therefore, the matrix will be having the last two elements 4 and 5. Therefore, AB exists and it is of order 2 cross 2. The elements of AB are 14, minus 6, 4, 5. Hence, the solution of a given matrix. My dear students, you can find out, you can try BA exists. If BA exists, then what are the elements of the matrix B? You take this as an assignment. Before I conclude my lecture, I would like to suggest you to practice these solved and assignment examples so that you will be perfect in getting accuracy. I thank for watching this video. For any difficulties or for any queries, please contact the given number. Thank you once again for watching this video. Stay home, stay safe.